In 7.2.1, we're supposed to be looking at point estimates and doing things like finding bias, finding the variance, etc. So for part A, we're supposed to find the bias, and I'm going to do it for mu1 and mu3, and then you can try the second one on your own. So the first one says that you would basically take two samples, or not full samples, two data points, just two data points in one sample. And you would divide each one by 2 and add them up. So basically it's like finding the average of them. And let's see if the average of that would then be equal to the population mean, or at least the expected value of it. So what we're doing is, I mean, it seems simple to us, like if we want to estimate, say, the population mean, we think it's simple to just take the sample mean, and the sample mean should be the same as our population mean. But that doesn't just happen automatically. We actually have to come through and find the proofs, and there are other things we could have done. So in this case, we're going to divide both of our values by 2 and add them together, and that will be our estimate of mu. So let's find the expected value of what that would be. Now this comes back to all of our rules from section 2.6, where we learn how to do combinations of random variables. So expected value of x1 over 2 plus x2 over 2 gives me, well, let's see, when you divide and multiply, those just come out of expected values. And then for each random variable, it's just you add up the expected values of each one. So it'll be like 1/2 times the expected value of x1 plus 1/2 times the expected value of x2. So again, those divide by 2 just come out as the 1/2, and then we just add the individual expected values for each random variable. Well, in our case, that's going to be 1/2. The expected value of x1 is mu, plus 1/2 times the expected value of x2, which is mu. So 1/2 mu plus 1/2 mu does give me mu. Because the expected value of this estimate for mu is equal to mu, our expected value means we think that we should be getting about what we want to do. This will be the bias, or this will be unbiased. Again, because the expected value of our estimate is equal to our population parameter mu that we wanted to calculate, it is unbiased. So let's try it for our third estimate. Our third estimate is x1 over 6 plus x2 over 3 plus 9. So the expected value of our third estimate, mu hat 3, is going to be the expected value of this x1 over 6 plus x2 over 6 plus 9. Okay, so expected value rules, the divide by 6 just comes out, so it'll be 1/6 times expected value of x1 plus, oh, sorry, one of those is a 6, this one is a 3. So plus 1/3 times the expected value of x2 plus 9. So the plus 9 just comes straight out of expected value. So this will be 1/6 times mu plus 1/3 times mu plus 9, which equals, let's see, 1/6 plus 1/3, that should be 1/2, right? So that should be 1/2 mu plus 9. Notice we are supposed to be estimating mu, but this doesn't give me mu, it gives me 1/2 mu plus 9. This is not equal to mu. So this is what we would call biased. Now when it's biased, you often want to actually find the bias. So to find the bias, we're saying, well, what is the difference between our expected value of our estimate and the population parameter? So bias in general is going to be, bias equals the expected value of whatever parameter we're estimating minus that actual parameter. So in our case, our bias is going to be the expected value of mu hat, which is this 1/2 mu plus 9, minus our actual parameter of mu. So let's see, 1/2 mu minus mu is going to be negative 1/2 mu plus 9, or you might want to write it as 9 minus mu over 2. So that is our bias. Technically up here if you wanted to find the bias for the first one, well, you would do the expected value of mu hat, whatever we got, which is mu, minus our actual parameter, which is mu, which is 0. That's how you know it's unbiased, because the bias is 0.